Today, we're going to be talking about relations. A relation is an ordered pair that follows a particular rule. An ordered pair that follows a particular rule. And when we're talking about an ordered pair, we're talking about an x and a y value, x and a y value. So this ordered pair follows a particular rule. Now, the x value, or what is known as the input value, or the domain is represented, or it's the first value. The x value, the first value, is known as the domain or the input value. The second value, which will be y is called the range or the output value. The output value. And the particular rule that it follows can be written in the form x is such that 2x, or x is mapped onto 2x plus 7. X is mapped onto 2x plus 7. And we could rewrite this also in this way. Y is equal to 2x plus 7. So if we see x is mapped onto 2x plus 7, or y is equal to 2x plus 7, we're talking about the same relation. This is the rule. This is the rule that maps the x value to the y value. This is the input value, so we input in our x values here, and the answer we get will be our output values. So here it says, state the ordered pairs for x mapped onto 2x plus 7 for any x value, or for the set of x values such that x is more than -2, but x is less than or equal to 2. So we write in the order pairs following this particular rule for the set of, once you see the curly brackets, it means set of, for the set of x values, these two dots mean such as, for the set of x values such as x is more than or equal to -2, but less than or equal to 2. So we're taking the range of values from -2 to +2, and we're finding the y values, our output values. So one way of doing that is this table. So what we do put our x values to the top. So our x values starting from -2 to +2. So -2, -1, 0, 1, and 2. Here we put our rule. So 2x and then plus 7. So this line is telling us 2 times x. So all the x values we're multiplying by 2. So -2 times 2. -2 times 2, that will give us -4. -1 times 2, which will give us -2. 0 times 2, which will give us 0. 1 times 2, 2. And 2 times 2, 4. So we did this part, the 2x part. We multiplied everything by our 2, right? By the 2, because it says 2 times x. And the next part says plus 7. So straight throughout, we add 7. 7 plus 7 plus 7. So we have -4 plus 7. That will give us 3. -2 plus 7, that will give us 5. 0 plus 7 should give us 7. 2 plus 7, 9. And 4 plus 7, which is 11. All right, so we found all our y values. So if we have to write the ordered pairs, we'll take our x value, and our x value, which is our input value, and our y value, which is our output value. So the first ordered pair would be -2, 3. Next ordered pair be -1, 5. Then 0, 7, 1, 9, and 2, 11. So here it is, we have our ordered pairs. Now, another thing we can do, or one more thing we can be asked to do, is represent it by a mapping diagram. Represent our ordered pairs using a mapping diagram. So a mapping diagram shows the input values, our x values, which is also known as our domain, and our output values, our y values, which is also called our range. So what we do, let's start by putting all our input values, -2, -1, 0, 1, and 2. Now, the rule that maps x to y, for these values to be mapped onto here, we have to follow the rule. We follow the rule 2x plus 7. So this rule maps the x values to the y values. So when we have -2, our y value is 3. So it's mapped onto that. -2 gives us 3. At -1 we have 5. Maps it. Alright, from -1 to 5, following this rule. 0 to 7, x to y, following this rule. Y to 9, which is 1 to 9, following the rule. And then to 11, following that particular rule. So this rule maps the x values to the y values. Alright? So the relation is a ordered pair, is a defined set of ordered pair that follow a particular rule. Right? Remember, the x values are our input values, or our domain values. Our y value is our output value, or our range. And this is the way we calculate the ordered pairs. So what we're going to do is we're going to do some more examples of calculating the ordered pairs with a particular rule, and drawing the mapping diagram to do so. Right, here is another example where we want to complete or find the ordered pairs and complete our mapping diagram. So let's go about doing it. Now we have x is mapped onto minus 3x minus 5 for any x value such that x is more than or equal to -3 and less than 2. Now remember, our rule, x is mapped onto minus 3x minus 5, can be written as y is equal to minus 3x take 5. So we can write it like this. No trouble. Same thing we're talking about. So let us set up our table. So we have minus 3x and minus 5. Listing our x values, x takes the values from -3 to +2. -3, -2, -1, 0, 1, and 2. Alright? So our first step, we have -3 times x. So we multiply -3 by every value there. So -3 times -3 gives us 9. -3 times -2, 6. -3 times -1, 3. -3 times 0, 0. -3 times 1, -3. -3 times 2, -6. Alright? So we multiplied all our x values by -3. And then we subtract 5. And since this is a constant, that goes right throughout. It is a constant. So we have 9 take 5, which is 4. 6 take 5, which is 1. 3 take 5, which is -2. 0 take 5, which is -5. -3 take 5, which is -8. And negative 6 take 5 gives us negative 11. So we have our values. Now to write our ordered pairs. Our ordered pairs will be minus, when x is minus 3, y is 4. When x is, when x is negative 2, y is 1. When x is negative 1, y is negative 2. When x is 0, y is negative 5. When x is 1, y is negative 8. And when x is 2, y is negative 11. So we have all our ordered pairs. Now let's draw our mapping diagram. Remember, the mapping diagram shows the relation, the relationship between the x values and the y values. So in our first set, we have our x values, and that is called the domain. And range will be our y values. So let's list our x values: minus 3, minus 2, minus 1, 0, 1, and 2. So for our y values, remember, it is following the relation minus 3 x take 5. This relation, or this rule, is mapping the x values to our y values. So when x is negative 3, y is 4. So we have that mapping. We have, when x is negative 2, we have 1. When x is negative 1, we have negative 2. When x is 0, we have minus 5. When x is 1, we have minus 8. And when x is 2, we have minus 11. So we have our mapping diagram. So we have our ordered pairs, we have our rules, we have the table how we got our ordered pairs, and we have our mapping diagram. We will do one more example of finding the mapping diagram, and we will do a special one when we have a quadratic expression. Now let's look at this relation. In this relationship, it says that x is mapped onto x squared minus 4x minus 5. When x is such that x is more than negative 3 and less than or equal to negative 5. It's more than or equal to negative 3 and less than and equal to negative 5. So let us use our table here to calculate our ordered pairs. So our x values start from negative 3 to positive 5. Alright, now our rule says first x squared, then minus 4x, then take 5. So x squared means that we're multiplying x times itself. So negative 3 times negative 3, negative 3 times negative 3 is 9. Negative 2 times negative 2, 4. Negative 1 times negative 1, 1. 0. 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. So we have all the x squared values. We square all the x values. Now, the next thing we'll do is multiply the x values by negative 4. Multiply all the x values by negative 4. So negative 3 times negative 4 will give us positive 12. Negative 2 times negative 4, positive 8. Then we'll have positive 4. This will give us 0. Negative 4. 1 times negative 4 will give us negative 4. 2 times negative 4, negative 8. Then we will have negative 12, negative 16, and negative 20. Alright, we multiply each x value by negative 4. So now we have our constant where we will subtract 5 right throughout. Now, so let us complete. 9 plus 12, take 5. 9 plus 12, take 5 will give us 9 plus 12 take 5 will give us 16. 4 plus 8 take 5 will give us 7. 1 plus 4 take 5 will give us 0. When we have 0 plus 0 take 5 will give us minus 5. 1 take 4 take 5 will give us minus 8. 4 take 8 take 5 will give us minus 9. 9 take 12 take 5 will give us 9 take 12 will minus 3 will give us minus 8. 16 take 16 take 5 will give us minus 5. And 25 take 20, which will give us 5, take 5 will give us 0. So we have our y values. Now to represent our ordered pairs. So we have negative 3, 16, negative 2, 7, minus 1, 0, 0, minus 5. Then we have 1 and negative 8, 2 and negative 9. All right, we will have 3 and negative 8, 4, negative 5, 5, and 0. So here we have our ordered pairs. Let's now draw our mapping diagram. Our mapping diagram, remember our x values here, y values here. So we're going from negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 1 more, 5. So this represents our x values. So let's start mapping our ordered pairs. Negative 3, 16. Then negative 2, 7. Negative 1, 0. Then we have 0, negative 5. 1, negative 8. 2, negative 9. Then we have 3, negative 8. Now, here we already have negative 8. So we don't write the next negative 8. So what we do, we map to that 8. Then we have 4, negative 5. We already have negative 5 there. So we map to that. And since we already have 0, we map this 5 to 0. So that is how we will represent this mapping diagram here. That's how we represent it. And in our next video, we will talk more about the different types of mapping diagrams, when we talk more about relations and functions.